right, we're going to go over your practice test for chapter 6, question by question. So for question 1, tell whether -1, 1 is a solution to this system. We're going to go ahead and substitute in my x and my y into my equation. So we have 2 times -1/2 minus y, which is 1, equals -2. 2 times -1/2 is -1 minus 1. I want to know, do these equal -2? Well, -1 minus 1, -2 equals -2. That's true. So let's substitute it in the second one. Is 1 minus 4 times -1/2 equal to 3? Well, a negative times a negative is going to become 1 plus 2. I want to know if that equals 3. 3 does equal 3. It's true. So yes, it is a solution. Number 2, you need to solve by graphing. So the first thing you have to do is make sure that they are in slope-intercept form. No, the first line, we have y minus 2 equals 1/3 x. All we have to do is add 2 to both sides. So to put it in y equals mx plus b, you have y equals 1/3 x plus 2. Your second line, you have 3y equals -2x minus 3. Divide both sides by 3. Make sure you leave it as a fraction so that you can write your slope equals -2/3 x minus 1. So let's go ahead and graph those lines. Our first one has a y-intercept of 2. So I'm going to go up to 2 and graph. It has a slope of 1/3. It's positive, so it's going up. So I rise 1, run 1, 2, 3. Rise, run 1, 2, 3. Down 1, left 1, 2, 3. Down 1, left 1, 2, 3. And then connect. Your second line has a y-intercept of -1. So I'm going to start down at -1. And it has a slope of -2/3, so I know it's going to be going down. So I go up 1, 2, to the left, 1, 2, 3. I found out where they intersected, but I'm just going to do another point so I get a better line. Up 1, 2, to the left, 1, 2, 3. Draw your line. Put your arrowheads on it. Right here is where they intersect. That's at -3, 1. Number 3. We have our very first word problem here. Kiara bought 4 blouses and 3 sweaters. Gia bought 5 blouses but returned 2 sweaters. It's very important that she bought a few days earlier. Kiara's bill was $172 and Gia's bill was $54. So we know that Kiara bought 4 blouses, 3 sweaters, and hers was $172. The question asks, what's the price of a blouse and sweater? So it says, hint, remember, define your variables. X, let's just say it's the price of a blouse, and Y equals your price of a sweater. To make Kiara's equation, her equation would be 4 times the price of the blouse plus, because she's adding on more, 3 times the price of a sweater, Y, equals her total bill was $172. Whereas Gia, she bought 5 times the price of a blouse, but since she returned 2 sweaters, she took away from her total 2 times the price of the 2 sweaters, and her bill was only $54. Now I'm going to go ahead, because my Y's are negative and positive, I'm going to go ahead and use elimination. So I want to make 3 and 2 a positive and a -6. So I have to multiply the top equation by 2 and the bottom equation by 3. When I do that, I get 8x plus 6y equals 344. Then I get 15x minus 6y equals 162. So when you add the 2 together, you cancel out your y's, bring your equal sign down, you get 23x equals 506. Divide both sides by 23, and you get x equals 22. Then substitute 22 into either one. I'm going to just do the first so I don't deal with negatives. So I have 4 times 22 plus 3y equals 72. 4 times 22 is 88. So we have 88 plus 3y equals 172. Subtract 88, and you get 3y equals 172 minus 88 is 84. Divide by 3, and y equals 28. So you get the price of a blouse, put your dollar sign, is $22, and the price of a sweater is $28. Make sure your dollar sign goes on the left. Number 4, the population of Mayberry is 1,485, while the population of Hermione is 900. The population of Mayberry has been decreasing, going down negative of a rate of 20 people per year, while the population of Hermione has been increasing, so that would be positive, by 45 people per year. If these rates remain constant, in how many years will the populations of the towns be the same? How many residents will that be? Well, we know that our two variables then, x is going to equal the number of years, where y will equal the total population. So for Mayberry, your total equation, or your total population, is the fact that you started out with 1,485 people, but you're decreasing. People are moving away 20 people per year, so 20x. We're at Hermione, they started out with only 900 people, but they are adding 45 people per year. I use substitution for this because they both were y equals. And whenever you do your substitution, drag it, drop it in for y. You have 1,485 minus 20x equals 900 plus 45x. So we need to get our x's on the same side. So let's add 20x, and you get 1,485 equals 900 plus 65x. Subtract 900 from both sides. 1,485 minus 900 is 585 equals 65x. Divide by 65, and you get 9 equals x. So in how many years? 9 years. Now you have to figure out the population. You can use either equation. I'm just going to go ahead and use Hermione. So we have y equals 900 plus 45 times 9. So you get 900 plus 405, which equals 1,305. So the number of residents, 1,305. Number 5, this one you really had to think about and really think about your clues. To help with the fundraiser, Miss Rummel baked a total of 23 pies. Each apple pie she baked used 3/4 pounds of apples, and each cherry pie she baked used 2/5 pounds of cherries. In total, she used the same number of pounds of apples as she did pounds of cherries. How many of each pie did she bake? Well, the first thing, let's define. X is asking how many of each pie. X would be the number of apple pies, and y equals the number of cherry pies. If you read through the very first sentence, it says she baked 23 total pies. So the number of apple pies, x, plus the number of cherry pies, y, has to equal 23. Now some other clues that are in here. Each apple pie was 3/4 pounds of apples. So 3 quarter pounds per apple pie. Then we know for each cherry pie, it was 2/5 pounds per cherry pie. This last sentence is a really, really, really big clue. It tells us in total, she used the same number of pounds of apples as she did cherries. So this last clue tells us that the total apple pounds is the same or equal to, the fact that it's the same is the fact that it's equal to the total cherry pounds. Well, we need to find out what the total apple pounds are. If it's 3/4 pounds per one apple pie and we have X apple pies, you'd have to multiply how many pounds are in one times the number of apple pies. So you would have 3/4 per one pie times the number of apple pies equals, well, there's 2/5 in one cherry pie times Y, or your number of cherry pies. So we have our second equation here, which is 3/4 X equals 2/5 Y. Now, personally, I don't like the fact that they have these fractions. So I want to clear my fractions by multiplying by the least common denominator. I'm going to multiply the left-hand side by 20 and the right-hand side by 20, which 20 is really 20/1. When I do that, my 4 and my 20, they can cross-reduce, and I get 1 and 5. My 5 and my 20 become 1 and 4. So I get 5 times 3, which is 15x, equals 2 times 4, which is 8y. Then we have our other equation, so x plus y equals 23. Now, I would do this by substitution, personally. Let's go ahead and let's just solve for x. So you would subtract y from both sides. So you have x equals 23 minus y. So we need to substitute this in for x. When you substitute that in for x, you have 15 times the quantity 23 minus y equals 8y. So when you distribute, 15 times 23 is 345 minus 15y equals 8y. You have to get your y's on the same side. So add 15y to both sides, and you get 345 equals 23y. Divide both sides by 23, and magically, we get the wonderful number of 15 equals C. So she made 15 cherry pies. Let's plug it back into this equation. It's much, much easier. Oh, C for cherry, which is our y, sorry. So we have x plus 15 equals 23. Go ahead and subtract 15 from both sides, and you get x equals 8. So she made 8 apple pies and 15 cherry pies. I would definitely go and try this out before you move on to your next question.